Today, we're diving into a technology that is, quite literally, building our world one layer at a time. We're talking about 3D printing in construction, from its earliest days to its absolute explosion in growth, and how countries like India are using it to build faster, cheaper, and way smarter. So, let's get right into it.
So, to really get why 3D printing is such a massive game changer, we first have to understand the huge problems that the traditional construction industry has been wrestling with for, well, decades.
I mean, seriously, just pause and think about that. For pretty much all of human history, building anything has been slow, it's been expensive, and it's been incredibly wasteful. But what if we're on the verge of completely rewriting those rules?
Right, so here are the big four hurdles. Projects can drag on forever. Labor isn't just expensive, the work itself can be really dangerous. You end up throwing away a huge amount of material. And architects, well, they're often stuck inside a box, limited by the rigid, straight lines of traditional formwork, those temporary molds that concrete gets poured into. The industry has been practically begging for a shakeup.
And that shakeup, that disruption, is coming from a technology that takes the basic idea of your desktop office printer and scales it up to the size of a house.
This is it. 3D concrete printing, or 3DCP for short. At its heart, it's what's called additive manufacturing. You've got a robotic arm that's controlled by a computer, and it follows a digital blueprint, squeezing out this special concrete mix, layer by layer by layer, building the walls right from the ground up.
Now, I absolutely love this analogy because it makes the whole thing just click. Picture building a brick wall, right? Now, get rid of the bricks. All of them, and just build the wall using only the mortar, stacking it perfectly, layer on top of layer, until you have a solid structure. That's pretty much exactly what a 3D printer is doing.
And this is what it looks like in the real world. You can see those individual layers from the nozzle. This ribbed texture has become the signature look of 3D printed buildings. It's not just a wall, it's like a fossil record of how it was made.
So, how in the world did we get here? This technology didn't just appear out of thin air. It's actually the result of decades of trial and error, taking it from a crazy idea in a lab to a real tool on actual construction sites. The modern story really kicks off around 2004 with a process called contour crafting. That was the proof of concept that showed, hey, you can squeeze out cement on a massive scale. Then, for the next decade or so, universities like Loughborough in the UK were busy refining the accuracy and the materials. By 2016, the tech makes the jump from the lab to the real world, with companies like Cobode and Icon starting to print actual houses. And now, we're seeing it scale up to public buildings and even multi-story homes. The pace is just incredible.
Okay, let's talk money. Because this isn't just a cool piece of engineering, it's an economic tidal wave. We are not talking about some small niche market. We are talking about a fundamental shift in one of the biggest industries on the planet.
Just get a load of this chart. The market is already worth over $15 billion right now. But the projection for 2035, it's expected to rocket to over $1.8 trillion. That's trillion with a T. That is an absolutely mind-boggling jump. And what's fueling that insane projection? It's the speed of adoption, a compound annual growth rate of over 61%. I mean, that's almost unheard of for an industry this big. It tells you that this tech is going from a curiosity to a mainstream tool at lightning speed. So where is all this happening? Well, right now, the Asia-Pacific region is leading the pack with over 41% of the entire market. And that makes sense, right? You've got massive needs for new infrastructure, booming cities, and governments that are actively pushing for new, affordable ways to build. Speaking of that region, let's zoom in on a country that is fast becoming a global hub for this stuff: India. It's really the perfect case study for how a nation can take this technology and run with it to meet its own unique goals.
You know, something special is going on when a world leader is commenting on a new post office. This quote from Prime Minister Modi really frames the technology as more than just a new way to build. It's a symbol of national pride and technological independence.
And here's where the rubber really meets the road. These are the hard numbers from that post office project in Bengaluru. The construction giant L&T got it done in just 43 days. Normally, that would have taken about 8 months. And on top of that, they did it for about 40% less money. This isn't a theory. This is a real-world project proving how insanely efficient this can be.
And here's the machine that makes it all happen. This is a gantry-style printer, pictured here at the Indian Institute of Technology, Guwahati. It just moves back and forth along that frame, methodically laying down bead after bead of concrete.
literally turning a file on a computer into a solid building.
But, and this is super important, the revolution isn't just about the printer hardware, it's also about the ink. Startups like Tavasta, which came out of IIT Madras, are creating their own special concrete recipes. They're mixing standard stuff like cement and sand with advanced materials like geopolymers and fibers to get a mix that flows perfectly but also sets up fast and strong. All this innovation in both hardware and materials is fueling explosive growth. The Indian market by itself is projected to be worth almost $9 billion in the next decade. That shows you this isn't just a flash in the pan, it's a core part of the country's long-term strategy.
So, what does the future look like? I mean, the potential is obviously huge, but it's not going to be a completely smooth ride. Let's take a clear-eyed look at where this is all going and the hurdles we still need to get over.
On the one hand, you've got this amazing list of pros. It's faster, it's cheaper, it's safer, and it gives architects incredible freedom. But on the flip side, these printers are expensive up front. There aren't enough people who know how to run them yet. And there's a key technical challenge called mechanical anisotropy. It sounds fancy, but the idea is simple. Think of a stack of paper. It's strong if you push down on it, right? But it's super easy to tear it apart between the sheets. It's the same idea here. The bonds between the printed layers could be a weak point. That's a major puzzle to solve, especially for tall buildings or places with earthquakes. And of course, the old building codes are still trying to catch up.
But even with all those challenges, one of the most powerful reasons this technology is taking off is sustainability. By only printing what you need, you slash material waste. And by totally getting rid of that formwork, all that wood and metal that gets used once and often tossed, you save an unbelievable amount of resources. It's just a greener, smarter way to build.
And really, that brings us to the ultimate question here. The tech itself is fascinating, sure, but maybe its greatest legacy won't be about fancy architectural curves or saving time on a construction site. By making it so much faster and cheaper to build, the real revolution might be in solving massive problems, like the global housing crisis or building emergency shelters after a disaster. It could make a safe, dignified home a reality for millions. So the question isn't just about what we can build, but who we can finally build for.